Okay, so I selected this question to actually check that whether you can articulate your thoughts very clearly for potential divider. So I selected this particular response for us to discuss. So here they are basically asking you what will happen to the V voltage if down here it has become the LDR and that your LDR has become a fixed resistor. Okay, that is what this question is trying to say lah. That the LDR and the fixed resistor are being swapped. Okay, so if you have not gotten if you have forgotten what the context of the question is, pause the video, take some time to read about it before you continue. Okay, so for this particular student, you can see that he's following very closely to what I suggest to state how the two components are connected. Actually, for this particular question, you are given like 4 answer line. I don't think they required this level of explanation, this level of detail. And what's more, it is still a arguable thing whether your fixed resistor and your LDR are in series or not, because in some textbook they actually argue that this is it is a established connection, and so it is a parallel it is not a series exactly lah. So I would suggest, since there's only 3 answer line, right, in Cambridge you do not, the level of detail required by the examiner is not indicated by the mark, is indicated by the number of answer line. So for this, you don't need to mention this. I think it is just additional risk that you are taking that can be taken out. So down here, the student mentioned that when the level of light falls, the resistance of LDR very good, because in many of the complex circuit, there are more than one component that have resistance. Some of you like to just say resistance increase. Then one way that during benchmarking, they may mark you down is that resistance of what yeah. So for those of you who I say resistance, then I go and doodle bracket question mark is because you didn't tell me resistance of what. So very good, this student. Resistance of LDR increase. So the correct relationship with light intensity at this point, okay, most likely I will give you my first 1 mark already. Yeah. Then it says potential difference, very good, across, excellent. Okay, many of you in your answer, you go and write what? Flowing through. Hey, hello, your voltage doesn't flow through, current will flow through. Then some of you say potential difference of LDR. Potential difference is not a property of the the component. Some of you say potential difference in, sorry, it is not something that can be inside the LDR. Okay, the only preposition that is allowed is across. Okay, across the LDR will increase, very good. Then it says the fixed resistor and the output is connected in parallel. Okay, fine, this is very clear. You want to include it, I leave it to you, but actually you don't really need to. For a 3 answer line question, you don't need this. Hence, the potential difference across, very good. Fixed resistor and the output is the same. Okay, so therefore the potential difference across the output will decrease. I really want to give you the 2nd mark because it's a very complete one, but I hesitate because they asked for the subject of the question was the operation of the new device. So if I were you, instead of saying so much about hence the potential difference I will actually cancel this and I will just jump into the part whereby it says hence the potential difference across the output will decrease, therefore my bulb will not light up when the surrounding is dim. Why do I include this line? Because it says operation of new device, right? Operation of device is what? Whether the light bulb will light up or not, what? Because if you look at this circuit, what is the only operation it does? Well, the operation it does, if you read the context of the question, is what? There is a light bulb, and the light bulb will actually be turned on if the output voltage is larger than 8, correct or not? So the operation is whether the lamp will turn on or not. So for me, I will just instead of writing so much about whether the connection is series, whether the connection is parallel, I believe that this particular 2 mark, 1 mark will be given to the logic, whether the level of light drop, the PD of the output will increase, decrease, things like that. 1 mark will go into that. And I think the final 1 mark will go to the operation of the device, which is whether the light bulb will turn on or not. Okay, then for question 8. For question 8, there's a small number of you, very good. I'm very proud of those of you who got it right. That means you really belong here. Then I still have a group of you calculation here, not very mindful, right? First of all, I don't know what is this. Upward force equals downward force. Okay, fine. Upward force equals to downward force, meaning that you have some form of idea that F net equals to 0. But look at this. This thing will either go like that or go like this. This is what we call a turning effect. So when things start to turn, I will not look at upward force equals downward force. When things turn, I will look at moment clockwise equals moment anti-clockwise. That must become your instinct. Okay? Then, what disappoints me even further is, can you see this 30 is what? This 30 is Newton cm, right? If you look at the original question, there is one more moment over here. I think it says 11 Newton cm. So actually this 30 Newton cm and this 11 Newton cm, they are not forces. They are moment. What are these moments? So one of the 30 Newton cm is trying to tell you that the weight of the iron arm create this 30 Newton cm. What is the weight of the iron arm? Maybe the weight of iron arm is here, and it created this particular moment about the pivot. It is 30 Newton cm. So this is my clockwise, anti-clockwise 1. Then after that, I think if you read, the contact at the fixed connection push downward on the contact. So down here, there may be a normal contact force acting on this beam over here, right? So this normal contact force will also produce a moment of 11 Newton cm, which is also an anti-clockwise moment. So I call it ACW2. Then what keeps this beam level is actually the upward force by this spring. So this upward force by this spring must be causing a clockwise moment, right? So what happened here? You should be able to see that it is this ACW1 plus ACW2 is being balanced by this CW1, right? So this CW1 is caused by the spring force acting 25 cm from the pivot. So down here should be F times 25, which is equals to 30 plus 11. Okay, then you go and solve. Yeah. Okay, then for part B, I'm actually quite surprised. Okay, if you look at, I just want to show you lah, if you are a marker, you look at these two answers. Which one will you bother to read? Obviously, I will spend more time to read here, right? Rather than like that. So actually your handwriting really matters. Okay, but anyway, this question is trying to ask you, right, how does the mechanism work? Why is it that when a current in the circuit breaker can actually cause the contact here to break? And this particular student say the current flowing through the, I guess is the circuit breaker, is larger than that of the current rating. So hence, the contact break. I know lah, I know that's what the trigger condition is. When you have a large current flowing through a circuit breaker, it will cause the circuit breaker to trip. Okay, fine. But the question is not asking you that. This question is trying to ask you, how does that work? Okay, so it's not asking you the trigger condition. Maybe you are saying that because of 1 mark. Okay, but it is not. So down here, okay, you don't need to repeat the trigger condition. But why I mark this student wrong? Okay, why I mark this student wrong is because he used the word hence. Okay, she is trying to say that when the current is big, then it causes the magnetization of the steel. No, it is not. It is not. Right? What causes the magnetization of the steel is because the current is flowing through a solenoid. Correct or not? If you have a current, a huge current flowing through a straight wire, can it turn the steel into a magnet, into a permanent magnet? Cannot. So you need to point out that when the current is flowing through this particular solenoid, right, this coil, then it magnetizes the steel core. Yeah. So I want you to highlight that it is the solenoid, the current going through the solenoid, then it magnetizes the steel. Do you need to comment on the alignment of the magnetic domains? No need. It's too detailed already. You only have 2 answer lines. So just focus on saying that the current flow through the solenoid causes the steel core to magnetize. As a result, it will attract the iron arm, and then it will open the circuit, or it will break the contact point. Good enough. And you can see such beautiful handwriting. You feel like you give marks, you see, right? You will tend to like, oh, okay, maybe this part doesn't contradict. Okay, close one eye, give mark. Yeah. Then after that, for part C, what is the advantage? No. Suggest why you cannot reset the circuit breaker. Down here, what happened is that you need to point out that the steel is a hard magnetic material, and because of that, once it becomes a magnet, it will become a permanent magnet, and as a result, the iron arm will always be attracted by this permanent magnet. And one more thing I just want to highlight, I forgot just now. When the current is flowing through, does the current go through the core? It doesn't. All these wire, the blue color one, are insulated from the core. So actually the current is flowing through the coil only. So I think one of you or two of you mentioned that the current flow through the core. It doesn't. Okay? It only flow through the coil. Can? Okay, so that's all. I hope you learn something from this subject day, especially on how to articulate, on how to find hints to approach questions that you have not seen before. Okay, that's all. Bye-bye.